What if tomorrow the internet died, where phone went dark, planes fell from the sky, and the cause came from 150 million kilometers away? This isn't science fiction. It happened once before, in 1859. In early September of 1859, people across the world looked up and saw the impossible. The night sky was ablaze with shimmering curtains of red, green, and violet light. Auroras so bright they could be seen near the equator. Gold miners in the Rocky Mountains woke up thinking it was dawn, only to find the sunrise was actually the northern lights. In the Caribbean, sailors saw colors in the night sky they had never imagined. Telegraph operators, the lifeline of 19th century communication, found their lines sparking, machines catching fire, and messages being sent without a single human touch. This was not a meteor shower, a volcanic eruption, or the end of the world. It was the most powerful solar storm in recorded history, an event so intense that if it happened today, it could cripple our modern technological civilization. This is the story of the Carrington Event of 1859. What happened, how it changed science forever, and why scientists fear it could happen again. The sun may seem like a calm, glowing ball in our sky, but in truth, it is a raging nuclear furnace, a turbulent ocean of plasma, constantly boiling and roiling with magnetic storms. Sunspots, solar flares, and coronal mass ejections are the visible signs of its unpredictable nature. Our star's activity follows roughly an 11-year solar cycle. Periods when magnetic activity increases, sunspots multiply, and the chance of massive solar storms rises. During these peaks, the sun can unleash billions of tons of charged particles into space at incredible speeds. Most of the time, Earth is shielded by its magnetic field, which deflects these solar winds. But sometimes, the sun launches an enormous, concentrated blast, a coronal mass ejection, CME, that is aimed directly at Earth. When that happens, the consequences can be spectacular and dangerous. It was an ordinary Thursday morning for Richard Carrington, a 33-year-old English astronomer. In his private observatory in Surrey, he was sketching sunspots on a bright, cloudless day. Suddenly, through his telescope's filtered view, he saw something unprecedented. Two dazzling points of white light erupted near a large group of sunspots. They flared intensely for about 5 minutes, then faded. Carrington didn't know it yet, but he had just observed the first recorded solar flare in history. 17 hours later, the effects reached Earth. On the night of September 1st to 2nd, 1859, Earth's skies transformed. Auroras, normally confined to polar regions, appeared across the globe. In Havana, Cuba, people saw bright red glows overhead. In Hawaii, green and crimson lights danced in the night. In Queensland, Australia, newspapers reported that the heavens appeared as if in flames. In the Rocky Mountains, miners awoke in the middle of the night, cooked breakfast, and started work, thinking morning had arrived. Telegraph networks across Europe and North America went haywire. Sparks leapt from equipment, some operators were shocked, and telegraph paper caught fire. Even when operators disconnected their batteries, messages still transmitted, powered entirely by the geomagnetic currents induced by the storm. When a CME is ejected from the sun, it travels through space at speeds up to several million kilometers per hour. If aimed at Earth, the particles arrive in 15 to 96 hours, depending on speed. The 1859 Event CME traveled in a record 17 hours, meaning it was already following another earlier CME, which had cleared the path of solar wind resistance. When these charged particles reach Earth, they disturb the magnetic field, creating what's called a geomagnetic storm. The storm induces massive electric currents in long conductors like telegraph wires, or in our modern world, power lines, satellites, and undersea cables. While beautiful auroras are the visible sign, the invisible danger is the surge of electricity and radiation that can destroy electrical systems. In 1859, the world's technology was still in its infancy. Telegraphy was revolutionary, but simple compared to today's vast electrical grids. The damage, though startling, was manageable. Imagine if it happened now. Today, our world is woven together by an invisible web of electricity and communication systems, power grids, GPS satellites, internet infrastructure, aviation control, and global shipping. A Carrington-level storm could cause massive blackouts lasting weeks or months, satellite failure, crippling GPS, communications, and weather forecasting, aviation disruptions, and dangerous radiation exposure for flights near the poles, stock market chaos due to halted transactions, freshwater and food shortages as supply chains collapse. According to a 2013 study by the U.S. National Academy of Sciences, the cost of such an event in the U.S. alone could exceed $2 trillion in the first year. We've had close calls. March 1989. A geomagnetic storm knocked out Quebec's power grid in Canada for 9 hours, affecting millions. July 2012, NASA detected a massive CME from the sun that missed Earth by only 9 days in its orbit. If it had hit, experts say it could have rivaled the Carrington Event in strength. These near misses serve as warnings. Our modern infrastructure is vastly more vulnerable than the telegraph lines of 1859. The good news is that we now have solar monitoring satellites like NASA's Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, watching the sun constantly. They can detect CMEs and give us 15 to 60 hours of warning before impact. But that's not much time. Power grids could be shut down preemptively, satellites put into safe mode, and flights rerouted. However, global coordination is challenging, and many countries have limited preparedness. In recent years, scientists and engineers have been urging for hardened infrastructure, such as shielding transformers, developing backup systems, and establishing emergency communication methods that don't rely on satellites or the internet. The sun's current solar cycle, cycle 25, is predicted to peak between 2024 and 2026, meaning solar activity and the risk of major storms is on the rise right now. While a Carrington-level event is rare, scientists estimate there's a 1 to 12% chance per decade. That might seem small until you remember that we have already had one close call in 2012. The Carrington Event was a natural wonder, a breathtaking display of the sun's raw power. For the people of 1859, it was a strange and beautiful disruption. For us, it's a warning. Our dependence on fragile, interconnected technology means that the next great solar storm could be the most expensive natural disaster in history. Not because of destruction to buildings or landscapes, but because it would pull the plug on the modern world. In the end, the Carrington Event reminds us of a humbling truth. We are at the mercy of our star. The sun gives us life, but in a single day, it could plunge our civilization into darkness. Stay with me, because in the next few minutes you'll discover how a single solar storm nearly fried the 19th century, and why scientists fear it could destroy our world today.